Okay, so today we're going to look at factoring difference of perfect squares, sometimes called DOPS, sometimes called DOTS, just an acronym for how to remember how to factor this. So there are three different requirements that we have here. Okay, the first, when I want to factor by difference of perfect squares, I have to have a binomial. Okay, binomial meaning two terms. The next, difference means subtraction. So there has to be a minus sign somewhere in my binomial. And the third is, well, they have to be perfect squares. Once I go through my checklist and make sure all three of these are true, then I could factor it by difference of perfect squares. So my first example here, 9x squared minus 16y squared. I go through, it is a binomial. There is a minus sign in between. 9 is a perfect square, x squared is a perfect square, 16 is a perfect square, and y squared is a perfect square. So we're good. We are going to set up two sets of parentheses for this type of factoring. And what I'm going to do is I'm going to take the square root of the first term. That's going to be my first term in both sets of parentheses. Deal with your numbers first. The square root of 9 is 3. The square root of x squared is x. Then I take the square root of 16, y squared, which is 4y. 4y. Remember, it has to be the same terms in both parentheses here. I take one plus sign and one minus sign. Having these are called conjugate pairs, the same two terms with different signs in the middle, allows the middle terms to cancel out. So if I were to check my answer by multiplying or distributing here, the middle terms would cancel out. So I'm left with my final answer, 3x plus 4y, 3x minus 4y. Another example here, down below, 3n squared minus 75. Now if I went through, yes, there's a binomial. Yes, there's subtraction sign. But are these perfect squares? No. Well, I do also have to look for, before I even check to see if I could factor by difference of perfect squares, I do need to look to see if there is a GCF, a greatest common factor, which we did in the previous video. 3 and 75, I could pull a 3 out of both terms here. So if I had a 3 all the way outside, I'm dividing by my GCF. I'm left with n squared minus 25. So if I were to cover up the 3 here, I can now factor this n squared minus 25 by difference of perfect squares. It is a binomial, there's a subtraction sign, and they are perfect squares. Two sets of parentheses. The square root of n squared is n. The square root of 25 is 5. I do have to take 1 plus, 1 minus. And what I do here is I bring down this 3, giving my final answer 3 parentheses n plus 5, n minus 5. Difference of perfect squares is not a very difficult topic here. However, people don't go through their checklist and they think that they could factor sometimes using difference of perfect squares when we didn't meet all of my requirements. So hopefully this video helped, and thanks a lot, guys.